Okay, I want to go over a more general definition of what we mean by mod or modulus. So we say here if G is a group and H is a subgroup of G, then A and B are said to be congruent mod H if A, B inverse is an element of that subgroup. That sounds a lot different than the classical definition of what most people typically think of when they say modulus, but it's really not, and I'm going to show you why. So typically, if you say something like A is congruent to B mod, let's say 5, for example, what that means by definition is that A minus B over 5 is an integer. Or another way of saying that is that 5 divides A minus B. Okay? Another way of saying that is that A minus B is some multiple of 5, or K is some integer. That's what we typically mean when we say modulus. That's how we introduce it in like a discrete course or a fundamentals course or an algebra course. And what I'm saying here is that this is a more general definition, because this definition that we just used, okay, is the standard definition in a certain group. So if you take the integers mod addition, or I'm sorry, integers with addition, and I let my subgroup be, let's say, the cyclic subgroup generated by 5. So these are all the multiples of 5. Then here, when I say A is congruent to B mod 5, notice we said here that that means that A minus B is 5k for some integer, or in other words, A minus B is a multiple of 5. So A minus B is in the cyclic subgroup generated by 5. So when we say A is congruent to B mod 5, and we're typically talking about the integers, what we really mean here is that A is congruent to B mod the cyclic subgroup generated by 5, which is a subgroup of the integers with addition. Because notice, this is, negative B is B inverse, so A times B inverse is, well, in terms of integers, we mean A minus B. So A minus B is an element of my subgroup. They are congruent mod cyclic subgroup generated by 5. Okay, so now this extends to broader context. So anytime you have a subgroup, you can start thinking about the modulus according to that subgroup. And the way you have to do it is through this relationship, is A, B inverse in the subgroup itself. Okay, this is a little bit more general, but this is a useful idea. It'll help actually prove Lagrange's theorem. If you have any questions on it, I'd be glad to help, and thanks for watching.